Today we're tackling one of science's most misunderstood concepts, entropy. So what is it really? Think about it. A glass shatters, but it never ever unshatters, right? So why not? The common answer you'll hear is entropy. This idea that things just tend towards disorder and chaos. But, well, that's not really the whole story. The disorder analogy is actually kind of misleading. The whole idea got started with steam engines. Clausius was studying heat loss, then Boltzmann completely changed the game.
At first, entropy was just a measure of how energy spreads out, becoming less useful for doing work.
But then, Boltzmann connected entropy to something totally different, probability. And this changed everything. Okay, first, a macroscopic state. That's just the big picture stuff we can measure, like a room's temperature. At a microscopic state, that's the nitty-gritty detail, the exact arrangement of every single atom in that system. So here's the key. A low entropy state means there are very few ways to arrange all those tiny parts. But a high entropy state? There are a ton of ways to arrange them. It's not about disorder, it's just probability. This idea was so powerful, it jumped from physics into a totally new field, thanks to some pretty funny advice. Yep, in the 1940s, Claude Shannon used the exact same math to measure uncertainty, but in information.
So whether it's atoms in a box or bits in a message, entropy is really just about counting possibilities.
And all this leads to one of the most fundamental rules of the entire universe, the second law of thermodynamics. Simply put, it says the total entropy of a closed system, like our universe, never ever decreases. It only goes up. But wait a minute, what about life? Or even an air conditioner? Don't those things create order? Well, yes, but only locally. To create order in one place, you have to create even more disorder somewhere else. Your AC cools the room by making things hotter outside. The total entropy of the universe always increases. It always wins. So, if entropy is always increasing, it leads to a pretty profound question. What's the ultimate fate of everything? One leading idea is called heat death, a final state where all energy is evenly spread out and nothing happens, ever again. So entropy isn't just chaos. It's a deep concept linking probability, energy, information, and maybe even time itself.